So the x1 we don't know. Y1 is what we're looking for.
Mm-hmm.
Do we know our velocity next?
No, we know y is 0 though.
Right. Okay. So we want to find position.
So we gotta solve for time first. Right?
Well, first let's look at what, so we know what we're looking for, and we know what we don't have. So we're looking for position, so that's one of these two equations, right?
Mm-hmm.
But we don't have time, so that rules out this one, right?
Uh-huh.
Could we use this one?
Let's see. Yes.
Yeah. You can say the final velocity is 0. Your initial velocity is 7.66 squared. Well, that's 7.66 and you square that. 2, negative 9.8 times the change in y.
Okay.
Now all you do is just solve for change in y, right? So you have negative 7.66 squared all over negative 19.6. Luckily your signs cancel again.
Okay.
So that's kind of a, of these three equations, you could do everything that those three equations can do with just the first two, everything.
Okay.
The last one is actually just basically a rearrangement of these two equations. They kind of stick them together.
Alright.
But what it does, so you know how you said, oh, so we need to solve for t. So you could have, you could have come here, if you ignored the, oh no. So you could have come here and found t pretty quickly, right? You could have said 0 equals 7.66 plus negative 9.8 t.
Mm-hmm.
Solve for t, and then plugged it back in here. But if you ever hear yourself saying that, if you say, oh, I want to solve for time and plug it in here, or oh, I'm going to solve for time here and plug it in here, just skip to this equation, because that's what they've done for you already.
Okay.
The way they got this equation is they solved this one for time. They said v final minus v initial all over a, that's equal to time.
Okay.
And they plugged that into this one.
Ah.
So that's where it came from.
Okay.
So anytime you say, oh, I just need to find time and I'll plug it back in, say, wait a minute, I can do this in one step.
Alright.
That's kind of a nice equation that they gave us. So what's this answer though?
2.993.
2.993. So not quite 3 meters.
Yeah.
Yeah, so about 49, yeah.
So that's the height?
Yeah, so that would be your maximum height, because you went, this is a change in y, which would be y final minus y initial.
Okay.
Your y initial is 0.
Ah. Okay. 0.9. Oh, I think the internet gave up on us.
Oh, really?
It says it's connected. It's like no refresh button on here though, so.
Try to maybe not.
Wake up. Of course. 2.99. Boom. Okay, and then the magnitude of the projectile's velocity at the instant it hits the ground.
Okay.
So we calculate that from the midpoint down? Or,
Actually, you can, so the nice thing about this is you can start from the beginning again. You can use the equations between any 2 points that the acceleration doesn't change.
okay,
So as long as the acceleration is the same from this point to this point, you can actually skip the midpoint. Remember how we stuck our midpoint in there anyway?
uh-huh,
So we'll just get rid of it for the sake of this part of the problem.
okay.
And what are we trying to find?
The magnitude. So, I don't know what magnitude's equal to, velocity.
So over here, this velocity vector has a magnitude of 10
Mm-hmm.
and an angle of 50 degrees, right?
Uh-huh,
So what we're going to be looking for on this side, the same thing happens, is we actually know this is lower, but you'll have a magnitude that looks like that, and then some angle in here. But we just want the magnitude.
okay.
So what is this magnitude made up of?
X and Y coordinates.
Yep, so we've got an x component of velocity and a y component. So these two.
Okay,
So if we can find both of these, then we can find our magnitude of velocity, right? So how are we going to find those?
let's see. Can we use the bottom one for that, or do we need time? I think we do need time, don't we?
We could use the bottom equation, but we'd have to solve this for distance first.
Oh. Okay. Well, we know B. Let's use the top one. Can we
Yes.
use-
Definitely. So let's go x. Vx2 is going to be equal to x initial,
Yeah.
6.427. Acceleration,
Let's see, 10. Oh, we're just worried about the gravity acceleration.
so which direction is this in, x or y?
X.
So we want to use our x acceleration.
Yeah.
Conveniently, 0.
Okay.
So it turns out this is that idea that acceleration is 0. It's going to move the same amount. It's always going at the same speed next.
Okay.
So anywhere we go on this projectile, or this trajectory, the velocity in x is going to be 6.427 meters per second. Okay, so that was easy. What about y?
Okay, so this one we use gravity.
Yep,
Um,
so looking at our equation.
Initial negative 9.8 meters per second.
Well, we want to use our initial velocity, right? So 7.66
Oh, okay.
minus 9.8. What's our time?
This is 0. 7.5 seconds.
Yeah. So with this equation, you're finding your final velocity.
Right.
So you plug in the initial velocity, how fast it was going at the beginning, which was 7.66, plus the acceleration, times the t. Anytime you see t in these equations,
It's the time at the velocity you're looking for.
yes and no. It's actually a change in t.
Okay.
So it would be the total time between whatever points you're looking at.
Okay.
So if this one's 7.5 and this one's 0, you're right, it's going to be 7.5. But say we tried to do this from this point, and we use time.
Okay.
You'd want to be careful not to use 7.5. You'd actually want to subtract whatever the time was here from that. So just when you're using these equations, remember that t is a change in time. So it's however much time it took to get from the first point to the second point.
Understand.
So what's that?
Let's see here. 7.66 minus 9.8 times 7.5. Okay, so negative 65.84.
And if you were to draw your total velocity, it was really big, negative 65.84. You'd still have your 6 over here in x, right? Actually, let's draw this at the bottom so it's a little easier. So 6.427.
7.
Your final velocity looks like this.
Okay. And we need to solve for the angle, is that what they want? Or
They want the magnitude, so it's the length.
the length, okay. So then it's just Pythagorean theorem.
Mhm.
Okay, so this squared. S- 6.27. Okay, so I got 65.525.
Alright. Oops.
That's not right though, is it?
Ooh, yeah, 525.
Yeah, that's smaller. What did I do wrong? Okay. A squared plus b squared equals c squared, right?
Yeah. So when you do the 65.84, make sure you don't put a negative in front of it.
Okay.
Because this calculator will take just the numbers and it'll leave the negative in front. So it'll square 65.84 and then make that negative.
Okay, 66.152.
Okay?
And it doesn't care about the angle?
Not yet. The magnitude is just the length of the vector. It might ask you what the angle is, I don't know.
Okay. 66.152. Sweet. Okay, and then the last one, what is the direction below plus x of the projectile's velocity at the instant it hits the ground?
So that's just saying this is positive x. That's the positive x-axis.
Uh-huh.
So what's the angle in here?
Okay, so now we can just solve that from our triangle.
Yeah.
Okay, so arc tangent, is that what you'd use? Alright, so opposite over adjacent.
Mm-hmm.
6 point. And I don't use the negative sign.
No.
5. Okay.
Did you get a really small number?
I did, yeah.
And you know that that's not going to be a small number, right?
Right.
So it might not be that your calculator's in radians versus degrees.
It might be that I gotta subtract it from 90.
Yeah, so what you actually did, you found this angle right here, right? Because this is the opposite side for this angle. This is the adjacent side for this angle.
Uh-huh.
But this angle right here is actually this one right here. Right?
Okay.
So if I'd drawn that the other way and put Vx up here and then Vy,
Uh-huh.
it would have been better. It would have been more accurate, I guess. You wouldn't have had to change angles like that, but just make sure you're finding the angle you actually want to find.
So I got 84.424.
So you could say this was 84.424 degrees below positive x, like that.
Okay. And then you don't have to put a negative sign or anything?
No, because it already asked you, it's saying what is the angle below the positive x-axis already.